are starting. It is recording.
Oh, hi.
Woo! It is starting. We are recording. Hey, there you all are. Yay. There's Crystal. Wave, Crystal. Okay. All right. Okay, so, like I said, today, brace yourselves, everybody. We have the longest notes of our lives.
Are these like longer than any notes we've taken?
These are longer than any notes you have ever taken in this class. Yes, they are.
Today is the day.
So here's the way that I'll tell you this. It really balances out. If you guys look up here for the rest, oops, you're right here. If you look up here for the rest of the week, this is really short, that's really short, and so is the one at the very bottom. So this is just, we're balancing it out so that you get all the really, really longer stuff done today, and then it's really short from this point on. So, yes. They all look very irritated right now. Okay.
I just feel that my face is because it's Monday.
It's Monday, that's true. Okay. Oh, okay. We need to take a pause for just a second. We're back now. Okay, so we're back now. Okay, so you guys, I didn't tell you. Our rec night on Friday was really awesome. For those people that showed up, it was really fun, and the video game room was really intense. It was really intense, but it was fun to watch everybody. The best part of all of it was the popcorn machine. It definitely was. Yes, it was. Okay. Okay, here we go. All right. So what we will do is we will go through some examples, and then, shh, that's your cue to stop talking. Shh. We're going to go through some examples, and then we'll take a little break about halfway through and give you guys a little stretch break, because like I said, this is a really long lesson.
Is this taking the whole class period?
Almost, yes. Okay, that's why I said we're going to take a little break when we get part of the way through. All right. So, we have a couple of concepts that we're focusing on today, but we're seeing them in a wide variety of scenarios, which is why there are so many examples. The two basic concepts that we're looking at that are new have to do with exponents and radicals and placing exponents strategically with radicals. That's one of them. The other one is writing radicals as fractional exponents and vice versa. So let's start with the one where you can move exponents around. Okay, so this first one, the cubic root of 8 squared. It starts out written like this, and we can simplify like this, but we can also write this as the cubic root of 8, in parentheses, squared. Okay, so the gist of that is that you can move exponents underneath the radical back and forth. So underneath the radical, outside of the radical. Underneath, outside, and it means the same thing. Now, why would that be helpful? Well, let's look at this. Everybody, what is 8 squared? 64. So the cube, this is equal to the cubic root of 64. Is there a number that we can multiply by itself 3 times to get 64? 4. So this equals 4. Okay, what about this one? This is why this could come in handy. If we're looking inside of the parentheses first, what is the cubic root of 8? Thane. 2. And 2 squared is 4. So one way that this property helps us is if we have humongous numbers underneath a radical and we want to deal with less humongous numbers. Okay, so that's one way, and then you'll see another way that is a little bit more strategic that we can focus on as well. Okay, next, the square root of 6y to the 3rd power. If we just look at the square root of 6y right here, the way that it is there anything that we can do to simplify that any further? No. Okay, so this is where moving that exponent is going to make a difference. We can move the exponent underneath the radical so that it says the square root of 6y to the 3rd power. Oops, we don't need that parentheses there. Okay, now how many people would agree that 6y to the third power is the same thing as 6y times 6y times 6y? Is it? No. Yes, true. It is. Good. Okay. And then, within that, we can write that as 6y times 6y times 6y. If we want to simplify this, we're dealing with a square root, which means we're looking for, what, pairs, triples, quadruples? Twos. Good. So pairs. So we have a pair of 6y's. Within each pair, who can tell me what happens? Thane?
One gets taken out, the other one goes outside of the square root.
Good. Everybody give it up for Thane. Okay, so you can see that the square root of, in parentheses, 6y cubed is the same thing as 6y root 6y. Okay? All right, questions on that. That's the first property. So that's the first property. Now we're going to move to the second one, which is writing without rational exponents. Okay, so in other words, a rational exponent is a fractional exponent. All right, so this is actually really easy. You just kind of have to get a practice with a few of them. All right, y to the 1/4 we want to write as a radical. So here's how this works. The denominator of the fraction that you have, that is always the index of the root. Anybody remember? Clap if you remember the index. It's a number that appears somewhere in here. Clap if you remember which one. Good, okay. And then the numerators, those stay with the variables. So stay with the variables. So if I want to rewrite y to the 1/4 as a radical, the index is the number that goes in this little v right here. So it's 4, the 4th root of, and then like it says up here, the 1 stays with the variable. So y to the 1st power. Okay, so does everybody see how all three of these things had a place in this radical? Yes. Now, do we need the 1 there to know that we only have one of them? No. So we can just write this as the 4th root of y. Okay, questions on that? Okay, so now we're just getting practice with the second property, and then we're going to combine the two together into one giant, fun type of radical problem that you all do not look excited to do, but that's okay. All right, so let's get our extra credit sheet up here. Can somebody tell me, the next one is 16 to the 1/4 power. 16 to the 1/4 power. Can somebody tell me, Rebecca, what goes in the V? Let's start there. In the V? The 4. Good. Okay, where does there's 16 and 1 left. Which one's the big number? 16, and then where does 1 go? Above it, but we don't need it. Excellent. Okay, so everybody give it up for Rebecca. All right, now, we do want to simplify as much as possible. Is there a 4th root of 16? Shuggy. Okay, we can break it down. So we can do 4 and 4, and then what and what?
And then 2 and 3.
Good.
And you do the same thing. You can cross out if it's 2 or 3.
This time we cross out, we have a quadruplet, so we cross out 3 of them, and then 1 comes outside. So the 4th root of 16 is 2. Everybody give it up for Shuggy. Questions? Okay. Let's show the next few of these. And I'm going to ask for a few volunteers to come up and actually do these. So we have 3a to the 1/2 power. We have x to the 3/2 power. And 8 to the 2/3. So, do I have 3 volunteers that would like to come up? If you have already gotten a point today, put your hand down. Okay, Jonathan and Alyssa and Brandon. Come on up. Let's get some music going. Gotta have music for this madness, right? That is x to the 3/2. All right. So, go ahead. All right, everybody try this out on your own and see if you can do the same thing. So the first one again is 3a in parentheses, the 1/2. And Jonathan is good. Every clap Jonathan. Right. X to the 3/2.
Wait, am I doing
Okay, let's just really quickly revisit a couple of these so that we can all make sure we're in agreement. So let's look at this one. First we have 3a to the 1/2. How many people agree with what's written up here? The square root of 3a to the first. Okay, now you guys tell me, are there any numbers that we don't actually need to write up here? Liz, we don't need the 1. Good. Why do we not need the 1? There's just one of them, so we don't need to write. Exactly. Good. Everybody give it up for Liz. Okay, are there any others that we do not need to write up here? Do we need the 2? Do we? Okay, so if you guys tell me, if I ask you to tell me what that equals, what does that equal? How do you know that? It's a square root. Do we need a 2 to know that we're looking for 2 numbers multiplied by themselves? No. So we'll just leave that one like that, okay? Next, x to the 3/2. Okay, are there any numbers that don't need to be rewritten here? We have the 2 is the index, x to the 3rd. The 2, why does the 2 not need to be written there? Good, it's sung even, very good. Nice voice. Okay, now, can we simplify x to the 3rd power? Sloan, how do we do it?
You can because there's 3 x's, so...
Good, so there are 3 x's, x, x, x.
And then you can root 2 of those x's, which will just cancel out under the radical.
Excellent, so we get x root x. Everybody give it up for Sloan. Okay, next, 8 to the 2/3. So we actually did this one in the very beginning. So that's the same thing as the cubic root of 64, because 8 squared is 64. And then a number that works here is what? With 4. Good. Okay. Questions? Okay. Now we're going the other direction. Write with rational exponents. So, in the last several problems, we started with fractional exponents and we went to radicals. Now we're going the other way around. So remember, in this, the index is always in the denominator of the fraction, and everything else is in the top. Well, in this case, if we're grouping them all together this way, it's like there's an invisible 1 out here, so it's a cubed b squared c to the 1/4 power, or if you want to put that 1/4 with each individual variable, you can do that too, to get a to the 3/4, b to the 2/4, c to the 1/4, just to make sure that you reduce any fractions that you can. So a to the 3/4, b to the 1/2, c to the 1/4. Okay, so either of those are decent answers. All right, how are we doing on questions on that? How much is there? Yeah, everything, right, exactly. Thank you. Okay, so you guys tell me this next one. The 5th root of x squared y over 16. So if so again, pretend that this is all to the invisible first power. Can somebody tell me, we need a numerator and denominator up here. Which one goes where? If you're using the last one as an example. Alyssa? 5 goes on the bottom, and what goes on the top? 1. Everybody give it up for Alyssa. Okay, now if we wanted to apply that 1/5 to each of these individual letters and numbers, what would it look like? Just like we did on the last one. Aiden?
It would be x. Is that a 2?
That's a 2, yeah.
So it would be x to the 2/6.
Good.
Then y to the 1/5.
Excellent.
Over 16 to the 1/5.
Excellent. Everybody give it up for Aiden. Woo. Cool. Questions? Yes, Shuggy.
I have a question. If it's just radical 6, is that invisible out there?
Yes.
Or
What?
1?
Questions? Brandon. You have to talk louder. This thing's super loud. No. Oh, sorry. Okay, you can leave it like this or like that. Either one. Good. Other questions? Okay. There we go. Couple more of the same type of problem. The cubic root of 7abc to the 4th power. We're almost at the halfway point. They look terrified. They look terrified. Okay, so what do we think? Aiden?
So it would be, you would take the 3,
Uh-huh.
and then on top, it would be 2 or bottom.
Bottom. Good.
4 over 3.
Good. 4 over 3. Everybody give it up for Aiden.
Yay.
Okay. And again, if you wanted to apply that 4/3 to everything in the parentheses, you could do that. So next one, the 4th root of x squared y to the 3rd power. What do we think on that? Go ahead, Aiden.
You would put the 4 at the bottom.
Good.
And you put the imaginary 1.
Good.
in the
Excellent. Give it up for Aiden again. Okay. And again, if you wanted to apply that 1/4 to everything inside, you could do that as well. How are we doing on questions? It's okay. It's not like it's ridiculously difficult. It's just that there are a lot of examples and, yeah. Cool.
Are you sure which number goes on top?
Okay. This one always goes on the bottom. And the other ones, they go on the top. Okay, so if you know, so that's why I said you could either write it as this or x to the 2/4, y to the 3/4. They both mean the same thing. You just want to reduce that 2/4 to 1/2. So either of those works. Okay. Other questions? Okay. Now, from last semester, if I gave you something like x to the -7th, could somebody write x to the -7th with a positive exponent? Okay, somebody other than Aiden. He's already going into the next chapter's worth of notes for extra credit. Cole. That just means all of you need to raise your hands more. Go ahead. Okay, good. So it's over 1 and then what? Excellent. Everybody give it up for Cole. Okay, so it becomes 1 over x to the 7th. Now, if we have the same exact concept here, except we have a fractional exponent, how would I do 5 to the -1/4? Sloan. Good, you move it to the bottom, so it becomes what? 1 over 5 to the 1/4. Cool, everybody get up for Sloan. Okay, so we're putting these in here because every time in the past, anytime I throw in fractions, people get freaked out and they think you do it differently. You don't do it any differently, just because there's a fraction there. Okay, so next one, 3xy to the -7/8. How do I rewrite this one? Olivia. Good, and you get what? Everybody give it up for Olivia. Nicely done. Okay, questions on that? Shuggy. Yep. As normal. No. That's why I threw these in here, because, again, anytime people see fractions, they think it's like a whole new way of doing things and completely different. It's not. That's the answer. Just like this one is the answer. Okay, other questions? Do we want to take a stretch break? You want a nap? I hear you. We want to take a stretch break? Yeah? We're, yes, we're at the halfway point now. Okay, well, we'll take a little stretch break. I'm going to go ahead and do this.
So, we need the numbers, talking 1, 2, 3, because if we didn't have math, they could charge us hidden fees on our cell phone bills and even on our taxes. So all we got to do is put in a little practice for the plumbers, the teachers, and even the physicians, the doctors, and the lawyers, even the musicians counting down. Like 1, 2, 3, 4. We can hear it on the beat and even read it on the score. Some say a waste of time. What are they doing it for? So they ain't no end up again. Sweeping up the floor. Shout out to Miss Miller and even Mr. B, Miss Barnett, and Mr. Humphreys from Algebra 2 to trigonometry. If it wasn't for math, then where would we be? Shout out to Miss Miller and even Mr. B, Miss Barnett, and Mr. Humphreys. Hi.
It's a pain in the butt. So what? I'm thinking about math.
Okay, ready? Here we go. All right, here's how we're going to go about this kind of problem. When we're saying simplify here, the goal is to get this into one radical that is as simplified as it possibly can be. So, what we have is 7 to the 1/3 power times 7 to the 3/5 power. Does anybody have any ideas about anything we could do with this problem? Shuggy? We can multiply them together, except that, what's the rule if I have something like x squared times x cubed? If I multiply those together, what do I get? 5th. Remember we add the exponents to get x to the 5th? So if I have to add 1/3 and 3/5 together, what has to happen? A common denominator. Good. Everybody give it up for Shuggy and Thane. Okay. So, if I want to have a common denominator, we have a 3 as one of them and a 5 as the other. So, Aiden. Good. Cool. Everybody give it up for Aiden. Okay. So we're multiplying the 1/3 by 5 because if we want to get a common denominator of 15, here, I'll write this bigger for you guys. So it's 7 to the 5/15 times 7 to the 9/15. Can you see that better up here? Okay. So now that we add those straight across, 5/15 plus 9/15 is how many 15ths? 14/15. Good. Okay, now, remember back when we were getting them into one radical? So remember, each number has a place there, which goes where? Shuggy? Good. 15 goes in the V. Good. Excellent. Everybody give it up for Shuggy. Yay. The end. We are done. Yeah, all right. Questions on that? Okay, next, when we have something like this, 5 to the 7/6 over 5 to the 5/6. Now what do we do with those exponents? Excellent. Everybody give it up for Aiden. He said to subtract them. So, Aiden, when we subtract, we get 5 to the how many sixths? 7 minus 5 is? Sorry, it's a 7/6 and 5/6. 2/6. Good. Everybody give it up for Aiden. Okay. Now, does 2/6 reduce?
Yeah.
To what?
1/3.
To 1/3. So it's 5 to the 1/3, which, again, if we want to write this as a radical, what goes where? Who can tell me? Let's put the numbers in. Look. Good. Do I need the 1 there? Why not? It's there either way. Okay, everybody give it up for Sloan. Sloan wants a nap. I know. All right, questions? How many people feel like this is not... Clap if you feel like this is not super complicated, it's just long. We can stop right here.
Is there more? Are we just doing the same thing for the next couple of
Sort of.
No, just keep going. I don't want to mess with it.
Okay, let's just do... This is the second to last page. Okay, the 6th root of 8. Notice how I change subjects really fast. The 6th root of 8. Okay, what does anybody... We've learned a lot today. Can somebody do something with this problem based on anything that we have learned today or in the past? Anything. Doesn't really matter what. Michael. Cool, everybody give it up for Michael. 8 to the 1/6 power. Now, some of us might be looking at that and going, okay, there is nothing we can do here. Sloan.
Wait, I'm not really.
Whoops.
Yeah, I mean, like, why would you want to make it a... Why would you want to make it... Well, I was
necessarily need to. Now, you guys tell me, since we're dealing with exponents and radicals, is there a way that I can write 8 in terms of some number to some power? Is 8 a number to some power? Liz? 2 to the what? Good. 2 to the third. Everybody give it up for Liz. Good. Some of us see where she's going. Everybody give it up for Liz. That was weak. That was weak. Okay. How many people agree that 3 is the same thing as 3 over 1? Okay, so when we multiply straight across, we get 2 to the 3/6 power, right?
Yes.
What is 3/6 reduced to? 1/2. Does everybody see how we're getting this to be a little bit smaller than it started out as? Okay, so then what goes where here? Somebody other than Aiden. Sorry, Aiden. You're already into the next chapter worth of notes. Go ahead, Liz. Yeah. That? Right here? Okay, so then what? Just like that? Cool. Everybody give it up for Liz. Now, are there any numbers that we don't need here? Go ahead, Liz. The 2. Which 2? There are 2 of them. And the V. Why not? Good. Okay, everybody give it up for Liz again.
Yay!
Okay. All right. Almost there. Almost there. We're almost done. Sloan.
Oh,
Is that a hand?
yeah, it was. I was just okay. So, it was just, can I just simplify?
Yeah, this one, let's just simplify if we can. The 4th root of x to the 4th and the 4th root of y to the 12th.
Then it would just become x.
Yep.
And y to the third.
Good. Everybody give it up for Sloan. Xy to the 3rd. Where did the y to the 3rd come from? You're right. Where'd you get it?
Well, I got it from the y, just divided 12 by 4.
Good. 12 over 4 is 3. Good. All right. Getting there, getting there, getting there. I think we may only have one other problem after this one. Okay. So, next one. Suggestions, any? Are there out there? What do we do? So the 12th root of x cubed y to the 6th. Anything that we can do. Anything. Doesn't matter what. Thane?
You can make that into x and 3 over 4 with x to the 3 over 4 power.
3/12. Okay, good.
And y to the, that's 6.
That's a 6. Yeah, sorry, no, it's kind of small.
Yeah, y to the 2/3 power.
Like that?
3, yeah.
Okay, good. Everybody give it up for Thane.
Yay!
Yeah, so the 12 is what goes in each denominator, and then the other ones stay in the numerator. Okay, from there, where can we go? We have x to the 3/12 and y to the 6/12. Olivia. Good, 1/2. Excellent. Everybody give it up for Olivia. So 1/4 and 1/2. Okay. Now, if we remember, the rule that we have is that whatever the denominator is ends up becoming the index, correct? Okay. We have 2 totally different denominators here, which we can't do if we want to combine into one radical. So does anyone have a way that we might be able to fix that? Cole? Okay, good. Let's have good. We're going to just take the y to the 1/2 and multiply it by 2. Since this already has a 4, good. Everybody give it up for Cole.
Yay!
So we get x to the 1/4, y to the 2/4, which if we want to write as a one giant radical, who can place things underneath this radical for me? Taylor. 4 in the v, good. X, y to the 2nd. Okay, do I need the 1 with the x? Why not? Good, that's good. Okay, so everybody give it up for Taylor. Okay, how are we doing on questions? Okay, we're all right? All the last one. Write as a single radical expression. We have the 4th root of 7 times the square root of 3. All right, again, back to what we've been doing. How do I write the 4th root of 7 with a fractional exponent? Rebecca? Good. And how about 3? 3 to the what power? 3 to the, okay, good. 3 to the 1/2. Everybody give it up for Rebecca and Thane. Okay. So now what do I do from here? Again, if I want to get these under one radical, the goal is to do something. Shuggy? Good? Good? Good. Excellent. Everybody give it up for Shuggy. Now, one thing that I'm going to do a little out of order from what Shuggy suggested is I'm going to write this in radical form before multiplying them. Okay, the reason is because they have different bases. Okay, so we can't necessarily multiply them right now. So if I want to put this as a radical, can somebody do that for me? Alyssa? Where the 4 goes where? In the V. Good. And then we have 7 to what power? For what? The first. Good. Times 3 to the... Good. Everybody give it up for Alyssa. Okay? So the last step is just to multiply these together. So 7 to the first is just 7. 3 squared is how much? 9. 7 times 9 is 63. The end. Okay. Questions? Okay. Cheer because we are done with today's half-an-hour long lesson. And that is your homework.